Okay, this is exercise 15B. I should rename this. Exercise 15B, further expansions. So, all we're doing now with 15A, it was always like 1 plus, 3x to the 7 or something. This first one was always 1. Today, we're just coping with the fact that it's not always going to be 1. And the best way to do this is examples. Now, it's always handy to have a thing of Pascal's triangle with you when you're doing these. 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1. Yeah, I'll go to 7, 1, 7, 21, 35, 35, 21, 7, 1. The syllabus explicitly states that it's only for small positive integers. So like this is n equals 2, 3, 4, 5, 6, and 7. Like I wouldn't expect them to ask anything above 7. 7 would be a stretch, frankly, in an exam, because it's a lot of time wasted on something that, like if you do it for n equals 4 or 5, you've shown that you know the exact same skill. Okay, so let's do A. We've got 2 take x, 3x to the 4. Let's start off by putting our, putting our expansions to the 4 in. So, 1, 4, 6, 4, 1. We're going to build everything around that. So those 1, 4, 6, 4, 1s were just from the actual expansions in Pascal's triangle. There we go. Now, the first term I've got is 2. So we're going to have times 2 to the 4 times 2 to the 3 times 2 to the 2 times 2 to the 1 and then times 2 to the 0. We just don't put it in. So they were all for the 2. Don't forget you always start at the highest power with the first one and work your way down. With the second one, it's the opposite. We start at the lowest power, which technically is 0, and then we work our way up. And that negative belongs with the second one, by the way. Technically, we would want to do minus 3x to the 0. We never bother writing that in. Like, why bother? Times minus 3x to the 1 times minus 3x to the 2 times minus 3x to the 3 times minus 3x to the 4. And then we do pluses in between each of these terms. Okay, so that first one becomes 1 times 2 to the 4, which is 16. Plus, we've got 4 times 2 to the 3, which is 8, times negative 3x, it's just to the 1. Plus 6 times 2 to the 2 is 4, times negative 3 squared is 9x squared, plus 4 times 2 times negative 3 to the 3 is negative 27x cubed, plus 1 times negative 3 to the 4 is positive 81x to the 4. Even if you don't know, like if you were struggling, if you had negative 3x to the 4 and you didn't know what that came to, that's the same as negative 3 to the 4x to the 4. This bit you can chuck in your calculator. Alright, I'm just going to highlight these ones so people know where that came from. No point colour coding some things and not others. Okay, now let's actually figure out what we got. We've got 1 times 16 plus 32 times 3 or 96 x. But that was minus, so it was going to be minus 96x. And then we've got plus 6 times 4 times 9. Ugh, I wish I had a calculator, 24 times 9. 4 times 9. Ugh, 36. carry the 3, 18, 21, 216x squared. The next one is 4 times 2 times negative 27. Well, I know it's going to be minus, and that's 27 times 8, 56, carry the 5, 16, 216. That was x squared, this is x cubed. I may have gotten some of these numbers wrong, I don't have a calculator. Plus 81x to the 4. And that's it. There's nothing I can simplify. That's that question. For question B, you're going to do it exactly the same. This time, our coefficients are 1, 5, 10, 10, 5, 1. We've got 5x to the 5, 5x to the 4, 5x to the 3, 5x to the 2, 5x to the 1, and then 5x to the 0. We don't bother putting that in. Okay, we've got 1/5 a to the 0, 1/5 a to the 1. Oh, I should be doing pluses in between each of these terms as I come to them. Times 1/5 a squared times 1/5 a cubed times 1/5 a to the 4 times 1/5 a to the 5. Wish I'd left myself some more room. Okay, now, so that's 1 times, oh gosh, what is 5 to the 5? Okay, I'm going to use Google as a calculator. 5 to the 5, 3125x to the 5 plus 5 times 5 to the 4, 625. It's the worst two I've ever done. 625x to the 4 times 1 on 5a plus 10 times 125x to the 3 times 1 on, yeah, I should do these as big fractions. 1 on 5a, 1 on 25a squared, plus 10 times 25x squared times 1 on 125a cubed, plus 5 times 5x times 1 on 625a to the 4 plus 1 times 1 on 3125a to the 5. Okay, now some of these 5s are going to start cancelling out. The first one obviously won't because it's 1 times 3125x to the 5 plus 5 and 5. I get 625x to the 4a plus, oh no, I should have left that pink, I don't know why I changed it. 125 and 25, well that goes into that 5 times. So that's 10 times 5, which is 50, x to the 3a squared plus 25 and this one's 5, and then this 5 and this 10 gives me 2. So I get 2x to the x squared a to the 3 plus, okay. Now, 5, 125, 5, 25, 1 on 25x a to the 4 plus 1 on 3125 a to the 5. And that's it. It's not actually that hard. It's just like a process that you have to persevere through.